Good morning, everybody, and welcome to your first video lesson. Today is November 25th, and we are starting our first real unit, which is Quadratics Part 1. And this first lesson is just an introduction. Remember, the beauty of doing a video lesson, you can pause it, you can change the speed if you want to go faster or slower. If you missed something I said or you didn't quite get it, remember you can pause, go back, listen to it again, and these videos will stay up for the entire quadmester, so you could always refer to them if you need extra help. You should have a handout from Mr. Hack that you're going to follow along with and fill things out as I fill them out in the lesson. Learning goals, they're always just going to be mentioned. You don't have to copy these down. But our learning goal for this first video lesson is to become reintroduced to quadratic data. Or if you didn't happen to complete the grade 10 applied math, then maybe this is the first time that you've encountered quadratic data. And we're going to look at them in terms of tables and graphs. And then we're going to start to recognize the general shape of a parabola and the key features. So we're going to start with a warm-up. You don't have to stress too much about it, just kind of filling out a table of values with a little word problem here. And this is the first handout, or the first blank you have on your handout. So you have just designed and started manufacturing a new style BMX. If you charge $155, you will sell 1,085 bikes. For every $10 increase in price, you will sell 70 less, and you will sell 70 more for every $10 decrease. So at this point, I would highly recommend that you pause the video and you copy down that word bubble with all the information in it. And then once you finish copying it, then hit play again. So we're going to fill out this table together. On the left here, you can see I have the sale prices already populated for you. In the middle, units sold. And then on the right, total revenue. Revenue is just money brought in by a company, so you multiply the sales price by the units sold. Again, don't stress too much about this. It's just kind of a warm-up, and it's going to lead us to some quadratic data. So I'm going to start at the 155 because in the question it says, if you charge $155, you will sell 1,085 bikes. So at 155, we know that we're going to sell 1,085 bikes. And if we multiply those two numbers together, we get $168,175. And again, this revenue, we should actually add dollar signs there. Now if I go from 155 and work my way up, so it says for every $10 decrease in price, we're going to sell 70 more. So if I decide to sell for 145 here, I'm going to actually sell 70 more bikes, or 70 more BMX, which means this would become 1155, and that's just adding 70. And then every $10 increase, or decrease in price, I should say, so as I go this way, I'm going to keep adding 70. So if I add 70 to the next one, 1225, ignore that little pen squiggle there, and if I add 70 more, 1295, and if I add 70 more, 1365, and 70 more, 1435. And then it says for every $10 increase in price, I'm going to sell 70 less. So as I go this way, I am going to sell 70 less, meaning I'm going to subtract 70 from every unit sold I had before. So if I start at 1085 and I increase from 155 to 165, that's a $10 increase. I know I'm going to sell 70 less BMX. That's going to result in 1,015. Keep increasing the price by $10. I'm going to keep subtracting 70 bikes. keep going. 735 and 665. So we've now populated the entire unit sold column, and we can now go through the total revenue. And if you would like to follow along with your calculator, you're just multiplying sales price units sold. You can pause it, fill out that entire total revenue column, and see if you get the same numbers as I do. If not, it's just simple calculator work. You're just multiplying those two columns. So we're going to fill these out together. So 150,675, and then 156,975, 161,875, 165,375, and then 167,475. And then we already did the middle one. We got $168,175. And then we'll keep going underneath that. And what you're going to notice is that these values actually start to repeat. So we ended up with 167.45 here, and we ended up with 167.475 there. So it repeated. And if you keep going, don't just assume they do. Actually make sure you're doing the calculations. But we ended up with another repeat value. And another repeat value. Sorry about those squiggles. Getting used to this new pen. And 156.75. And then 142.975. So that's just putting all of those things in our columns, just using that little bit of word problem that we have. And the next thing that you are supposed to do with your handout is graph. And you're going to graph the number of bikes sold versus revenue. So coming up with a graph and coming up with a scale is definitely a skill that you're going to need to have for this course. So we're going to graph units sold. So this should be along your x-axis, and then total revenue, that should be along your y-axis. And make sure when you're coming up with your graph, give it a title, label your axes, and then you're going to have to come up with a scale. Now I'm going to give you a scale that I came up with by hand. It doesn't have to be exactly this way, but some key things here. So, and again, those numbers are kind of popping up across the picture. There's no way really I can get rid of that, but you're going to notice I have BMX sales, so we have a title. We have our y-axis is revenue, so right there, and that's in thousands of dollars. And you're going to notice that I made it in thousands, so I can write less numbers. So you're going to notice I wrote 142, 146, 150, 154, 158. I didn't write those hundreds of thousands numbers just to save us some writing, so that's why I wrote thousands up here. And you're going to remember, hopefully you remember, these little jump ahead symbols right here, so we can jump ahead. And I just went up by 2000s, so 142, 144, 146, 148, 150. And we had to go, our lowest number we had was 142,000 and change. Our highest number was what, 168 and change. And then on the bottom, the number of bikes sold. And then the lowest we had was 665. The highest we had was 1465. I just went up by 50s. So again, I used the jump ahead, started at 665, and then started going up by 50s. And I plotted my points. They're not going to be exact. You're just guesstimating, but you should roughly have that kind of sketch going on yours. And then if you connect them, again, we're not going to connect them. It obviously doesn't make a straight line. So you're going to connect those with your best attempt at a smooth curve. Arrows on the end. Now there is no equation here, so we didn't have to label our equation. And then to answer our question that we have there, the max revenue is, So we could look at our table of values. Our max revenue is $168,175 when you sell 1,085 bikes. And then the question at the bottom of your handout that says, is it quadratic? Yes or no, and why? There's a couple different things we're going to say here that you could write in. So it is definitely quadratic. We can look at the values in our table. So if we look at all these values that we got in this column, they actually repeat. So they go up, they reach a max or a pinnacle, and then they come back down and they actually repeat. So that's one way you can tell if something is quadratic, is if you have repeating values in your table of values. The other way, just looking at the graph, looking at our sketch, it makes that parabolic shape. So you're going to either, with quadratics, you're going to either end up with something that looks like this, or you're going to end up with something that looks like that. Clearly ours looks like this one right here. So it goes up, reaches a peak or a maximum, then comes back down. Or if we didn't end up with a scenario like this, it could be like the other one. So starts, goes down, reaches a minimum, and comes back up. So your answer to your final question, is it quadratic? Yes, it's quadratic. You can give two reasons. The table of values, the numbers repeat, or you could say it makes a parabola shape, goes up, comes back down. The next thing in your handout. So again, that was just a warm-up. Don't stress too much about that if you're wondering where those values came in or not. It was just kind of a warm-up and getting us into something that looks like a parabola. So now we're going to move into the key features of parabolas. So we're going to fill in these things together, and I've split this into two slides. So you're going to have, we're going to work with the top half first, then we're going to go to the bottom half. So if we work on the left, so this arrow right here that's pointing to this dashed line up the middle, that is actually called the axis of symmetry. And sometimes I summarize that as AOS. So that dashed line up the middle is basically the line that cuts your parabola in half. So it's a line with an undefined slope. If you remember from grade 9, a perfectly vertical line has an undefined slope. It goes through the center of the parabola, which makes it symmetrical on both sides. That's why we have repeating values in our table of values when we graph parabolas, because they're symmetrical, they're equal on both sides. If you folded that parabola along that dashed line, they would be mirror images of each other. Now the equation of an axis of symmetry is always x equals, and it's going to be x equals whatever that dashed line goes through. So in this case, if we're taking a look, my dashed line goes through -1. So in this case, my equation is x equals -1. Over here on the right, this arrow is pointing to where my parabola crosses the y-axis. So that is my y-intercept. And that's just the place where the parabola crosses the y-axis, which we already knew that. One thing we are going to add to this that I've already mentioned a couple times, there is only two ways that a parabola can open. So it can look like this, and if it looks like a U, we say it opens up, and it's also a positive. Remember, that's my short form for positive. It's also a positive quadratic or positive parabola. And in this case, this one that we have here is opening up, so we know it's positive. The other way, this was like our BMX question, it could open like that, and if it makes a hill shape, then we say that it opens down, and it's not a positive parabola this time, it would be a negative parabola. Moving down here on the bottom right. So if we look here, this arrow that's pointing right here. So that's a special point. So where it comes to an absolute bottom or it comes to a max, that's actually, and we're going to do a lot of work with it, that's actually called the vertex. In this case, it's a minimum because that's as low as my parabola gets. So in this case, it's also called the minimum. When the parabola opens up, because it represents the lowest point. So my parabola does not get any lower than -4. When the parabola opens down, it makes a maximum. And for the exact same reasons, because if it opens like this, it doesn't get any higher than that point at the vertex. Moving on to the left here, so in the middle, this thing that has two arrows, and they seem to be pointing to where my parabola crosses the x-axis. Those are called x-intercepts. Now you're also going to see them pop up with different names throughout the next two units. So they're also called roots, solutions, and zeros. So x-intercepts, roots, solutions, zeros, they all represent the same thing, and it's where your graph crosses, where your parabola crosses the x-axis. Now these have different forms, so you can write it as x equals. So if I look at mine, I have an x-intercept there and there. So that one right there, x equals 1, and then you would write comma, and my other one is -3. That's one way you can write it. The other way you can write it is as coordinates. So the coordinate right there is 1, 0, and the coordinate right here is -3, 0. So there's two different ways that you can write x-intercepts, root, solution, zeros, all the same thing. So that pretty well does it for all of the key terms that you're going to see in this first bit of quadratics for a parabola. Now I have a little bit of a challenge here. So we're going to talk about this and see if we can come up with the right answer. So if the axis of symmetry were x equals 3, so I'm going to put a dashed line, so remember axis of symmetry, dash vertical line. So if I had an axis of symmetry at 3, and one of the roots was at 6, so I'll put a dot right here, point right here, and I knew one of the roots was at 6, where would the other root be? So to think about that, if we're looking at our definition, the axis of symmetry cuts my parabola in half, which means both sides are symmetrical. So what that means if we're thinking about this is if my right side is symmetrical to my left side, I go 1, 2, 3 to get to my first root. So to get to my root on the other side, 1, 2, 3, my other root would be right there. So my axis of symmetry is always halfway between my x-intercepts. So my answer would be 0, 0 would be my other root. Our first example, real example, is not the warm-up. We're going to use the table to find first and second differences and decide if it is linear or quadratic. So we know by looking at the shape now, if it makes a parabola that opens up or down, it's definitely quadratic. If I look at a table of values, how do I know if it's quadratic? And we've already talked about this. If you start to see repeat values, which we do, we can safely assume that this is quadratic. However, the better way to do this is to prove it doing first and second differences. And you would have done first differences in grade 9 And then depending how much of your grade 10 course you paid attention to, you also would have done this. But we're going to go over it again. So when you're doing first differences and second differences, you only ever do the y column. Never the x. So only ever the y's. And what I like to do is I like to draw an arrow from the bottom up, or I make this little like staircase looking thing. So we're going to make this, ignore that squiggle, and I'm going to put an arrow on the top. And that helps remind me that I go bottom up. And when you see the word difference, what does that imply? To me, if I see the word difference, doesn't mean add, doesn't mean multiply, doesn't mean divide, it means subtract. So I'm going to put a little subtraction sign here to remind me that I subtract. And then you fill in the numbers. So if we start at the bottom, 1 minus 6 gives me negative 5. And then 6 minus 9 gives me negative 3. 9 minus 10 gives me negative 1. 10 minus 9 gives me 1. 9 minus 6 gives me 3. 6 minus 1 gives me 5. When you are at that point, you're going to ask yourself, are those numbers in that first column the same? And obviously they're not, they're all different numbers. However, if they were the same, which they're not, but if they were, that would be something you would have worked with in grade 9 in the first half of grade 10. So if first differences are the same, then it's linear. Those are not the same numbers, so they are definitely not linear. So we're going to do it again. And we're going to do the same thing. Draw that little staircase, bottom up. I like to put an arrow on the end to show that I went bottom up. Difference means subtract. Now we're going to be subtracting negatives, and you're going to end up with 2 negatives. So I would say, again, you're following along with me, but make sure when you're doing this on your own, don't just assume you know the answers. Make sure you're using your calculator. So negative 5 minus negative 3 gives you negative 2. Negative 3 minus negative 1 gives you negative 2. Negative 1 minus 1, negative 2, 1 minus 3, negative 2, 3 minus 5, negative 2. Are those all the same number? And you should be nodding your head, yes, those are the same number. If second differences are equal, it is quadratic, meaning it makes a parabola. So again, to review, first differences are equal, it's linear. Second differences are equal, it's quadratic. Now, if we didn't get the same number all the way through that second column, I would say double check your math to make sure you did it correctly. And if you still get the same answer and they're not all the same number, then you would say it's neither linear nor quadratic. Now, we need to finish this up with a therefore statement. So we are going to say, therefore, it is quadratic. And you need to tell me why. So because second differences, and you can say were the same, they were equal, they were constant. I'm going to say it's quadratic because second differences were equal. If it was linear, if you got first differences, that column to be the same, you'd say it's linear because first differences are equal. And like I said, if you double checked your math and none of the columns were the same number, then I would say that you would write it's neither quadratic nor linear because none of the differences were equal. And we can even build this a step further. Because we got negative 2 there, it's actually a negative parabola, and we could say that it opens down. And going back to the first little thing that we did in our warm-up activity, if you're looking at the table of values, 1, 6, 9, 10, 9, 6, 1, it's going up, coming back down. We have repeat values, lots of different ways to tell if something is quadratic so far, just by looking at a table of values or a graph. 1b, I want you to try this on your own. So basically follow the exact same process I just did, and you should pause the video at this point, try it on your own, hit play once you have it done, and see if you come up with the same thing that I'm about to get. So welcome back. Hopefully you paused it, tried it on your own. We go bottom up, and we're taking the difference, so we're going to subtract. 20 minus 10 is 10, 10 minus 4 is 6, 4 minus 2 is 2, 2 minus 4, negative 2, 4 minus 10, negative 6, 10 minus 20, negative 10. Are those all the same number? No, they're not. Hopefully you didn't get those to be all the same number, so we definitely know that it's not linear. So we're going to do it again, bottom up, and we're subtracting, and we're only ever doing the y column, don't forget that. 10 minus 6, 4, 6 minus 2, 4, 2 minus negative 2, be careful, 2 minus negative 2 is actually 4, negative 2 minus negative 6 is actually 4, and negative 6 minus negative 10 is also 4. Hopefully you got all 4s in this column. If you did, high five someone around you or high five yourself. Good work. Is the second column all the same? Yes, they are. So hopefully you picked that it was quadratic. So therefore it is quadratic, and you should write because second differences are equal. And again, you look at your y column, just another self check. We have repeat y values, so we probably should have been thinking already that it was quadratic, and my numbers are actually decreasing. 20, 10, 4, 2, 4, 10, 20. If I look at 4, that's a positive number. That means this is a positive parabola, a positive quadratic, which means it opens up. And that means that it comes to an absolute minimum. But we're going to work more on those things later today and tomorrow. So that's it for our first video lesson. I didn't want to make it too long. So some keys of our lesson today, or our first lesson: the graph of a quadratic opens up or down, opens up or opens down. And an easy way, if it makes a U shape, the word up starts with U. And quadratic relations, which just another word for equations, quadratic relations have second differences constant or equal. So that's it for our first video lesson. All I want you to work on right now, while you wait for me to come at 10:15, is in your workbook, work on what section 1.1, question number 1. And if you get done that, then you're free to just sit there and chill till I get there. And remember, when I get there at 10:15, I am going to collect your course information sheets if you haven't returned them yet. So remember, if you want that bonus mark, then you need to hand me your signed forms in when I get there. They're still going to be due even if you don't. I still need them to have those signatures. And then if you haven't done your scavenger hunt of D2L, then you could also work on that and get that done by 10:15 and hand it in to me if you're done to get another bonus mark. So 2 bonus marks on the test that you just wrote yesterday. Hopefully this wasn't too bad. Again, I apologize for the squiggles. I'll see you in a bit.